Hey there, welcome back. I'm Flat Rate Mechanic, and today we're diving into a common yet super frustrating issue, the Chevy Cruze stalling, specifically when it won't restart. If you've ever experienced that hair-pulling moment when your car just cuts out unexpectedly, then you know how annoying it can be. So, what do you do when you've got a crank no-start situation and no codes to guide you? Let's explore that together. First, let's paint a picture of the scenario. I've got a 2012 Chevy Cruze LT with a 1.4-liter turbo engine in the shop today, and it's dealing with one of those pesky intermittent problems. The owner has reported random stalls while driving, and sometimes the car just won't restart. I ran this thing for about half an hour, and guess what? It stalled a few times, and now it won't start at all. Now, here's the kicker. When I hooked up my scan tool and checked for codes, I found absolutely nothing. Zilch. This is one of those moments that can really make diagnosing a problem tricky because you're basically flying blind without any direction from the computer. So, where do we start? Let's get into understanding this intermittent stalling problem. When the Cruze is running, it can just cut off, like someone's flipped the ignition switch. There's no sputtering or warning signs, and when you try to restart it, it cranks and cranks but won't start. However, the owner mentioned that if she lets it sit for a bit, it starts right up again. That's a huge clue. This suggests the issue likely occurs when the engine gets hot. Now, a quick safety note. If you're diagnosing a hot engine, be careful. Those 1.4-liter turbos can get really hot. Wear your gloves and safety glasses and give things some time to cool down if needed. You might be wondering what to do next, right? Even without any codes, the scan tool is still our best friend here. What I did was access the engine control module and monitor live data, starting with the crank sensor. This is crucial because when the engine stalls, it feels like the ignition is just being shut off. I dived into the data stream and looked for the crank signal. Lo and behold, while I was monitoring, the engine cut off again. Now, it's important to graph the engine speed signal so we can visually see what's happening. I found the RPM signal on the scan tool and created a graph to monitor it. If the RPM signal drops to 0 when the engine stalls, we know we're losing the crank sensor signal. And here's a fun twist. Sometimes these intermittent problems have a mind of their own. I had the Cruze running with the scan tool for 3 hours, and guess what? It didn't stall once. This is classic behavior for intermittent issues. Now let's consider some common causes. The first thing that comes to mind is the crankshaft position sensor. This is often the main culprit in these models, especially from 2010 to 2015 with that 1.4-liter turbo. When this sensor starts to fail, it often happens when the engine gets hot, just like what we're seeing here. If the crank signal drops out, the engine will stall. Boom. Of course, there's also the possibility of a failing fuel pump. If it's cutting out intermittently, you'd get the same symptoms. You might even hear it struggling or notice it doesn't prime when you turn the key. Now, in my case with this Cruze, the actual problem turned out to be a corroded connection at the ignition coil. When things got hot, the connection broke and the coil lost power. Once it cooled down, the connection returned and the car would start again. This just emphasizes how critical it is to check your electrical connections, especially with these intermittent issues. Alright, so how do you test these components? First, use your scan tool to monitor live data. For the crank sensor, checking the resistance with a multimeter is essential. You're looking for a reading between 500 and 1500 ohms. If it's infinite, that sensor is bad. But be mindful, a sensor can pass a cold test and fail when hot, which is why live data is so important. While you're at it, don't forget to inspect the wiring harness and connections closely for any signs of corrosion or damage. Sometimes the issue is not with the sensor, but with the wiring itself. If you can get the engine to stall while wiggling the connector, that can be a huge clue. After hours of testing and monitoring, I finally found that corroded connection at the ignition coil. Cleaning it up with some contact cleaner and applying dielectric grease solved the problem, and after a good test drive, there were no more stalling issues. To sum it up, before you start replacing expensive parts, spend a little time checking your electrical connections. A can of electrical contact cleaner and a few minutes of your time can save you hundreds. So what are the takeaways here? First, always monitor live data to catch intermittent issues. Second, don't overlook the importance of your electrical connections. And lastly, if you ever find yourself in a similar situation, remember to be thorough with your inspections. Thanks for listening, and I'll catch you in the next one.